The Moon Impact Probe, developed by the Indian Space Research Organisation, India's national space agency, was a lunar probe that was released by ISRO's Chandrayaan-1 lunar remote sensing orbiter, which in turn was launched, on October 22, 2008, aboard a modified version of ISRO's Polar Satellite Launch Vehicle. It discovered the presence of water on the Moon. The Moon Impact Probe separated from the Moon orbiting Chandrayaan-1 on November 14, 2008, 2006 and crashed, as planned, into the lunar South Pole after a controlled descent. The MIP struck the Shackleton crater at 2031 on November 14, 2008, releasing underground debris that could be analyzed by the orbiter for presence of water ice. With this mission, India became the fifth entity to reach the lunar surface. Other entities to have done so are the former Soviet Union, the United States, the European Space Agency and Japan. Kalam's vision. The probe was a product of former President Abdul Kalam's vision, who felt that since the Chandrayaan orbiter was already going so near to the Moon, the mission would have more scientific relevance if the probe was included. He believed that the Moon could not be left to a few countries and that India should not be left behind. The Times of India also reported a political motive by former President Abdul Kalam, as he believed that if this was done, India could always stake a claim to a portion of the Moon. At the same time, the Indian Express reported Kalam as saying no nation can claim the Moon as its own. The resources of the Moon should be a common property, and that is one of the aims of the Moon mission. Mission objectives. The main objectives of the MIP were to demonstrate the technologies for reaching a specified location on the Moon, qualifying technologies required for any future soft landing missions, and scientific exploration of the Moon from close range just prior to the impact. The probe was designed to collide with the lunar surface and eject underground soil, which could then be analyzed by instruments on the orbiting Chandrayaan for the presence of water ice, and organic and other materials. Configuration and payloads. The MIP carried 3 instruments: radar altimeter Euro, which measured the altitude of the probe during descent and provided information on qualifying technologies for future landing missions. The operating frequency band was 4.3 GHz at ±100 MHz. Video imaging system Euro acquired close-range images of the surface of the Moon during descent and before impact. The video imaging system consisted of an analog CCD camera. Mass spectrometer-based payload Chaser Euro measured trace constituents of the lunar atmosphere during descent. This instrument was a quadrupole mass spectrometer with a mass resolution of 0.5 and sensitivities to partial pressures on the order of 1.3 A, 1011 pascals. The probe used aluminium sandwich structure onto which the payloads were mounted. The probe attached to the mother spacecraft with a ball lock separation system which jettisoned the unit from the Chandrayaan. A solid propellant deorbit motor nudged the craft into lunar orbit, while spin thrusters stabilized the orientation-enabling imaging system to capture the descent profile. The probe's external surface had 4 oval-shaped anodized aluminium plates measuring 120 mm x 180 mm, on which the image of the Indian flag was depicted, complete with the emblem of India and the word Satyameva Jayate. These plates were attached to each one of the 4 vertical sides of the probe. As per ISRO specifications, these plates had to endure a temperature range from -50 degrees Celsius and as high as +150 degrees Celsius. Mission chronology. India launched a Chandrayaan-1 spacecraft using a modified version of the PSLV-C-11 on October 22, 2008 from Satish Dhawan Space Center, Sriharikota, Andhra Pradesh at 6:22 IST. The lunar probe separated from Chandrayaan-1, in a 102-kilometer circular polar orbit around the Moon, at 20:06 IST on November 14, 2008. After separation, it first fired its spin-up rockets and then its retro-rocket to lower itself to an orbit intersecting the lunar surface. While descending, the MIP continuously sent information back to the Chandrayaan-1 orbiter, which in turn beamed the information back to Earth. After a 25-minute controlled descent, it struck the Moon at 2031 IST, November 14, 2008 at a speed of 1.69 km per second. The crash destroyed the probe. It crashed into Shackleton crater, At the lunar south pole, 89° S 30° W, at 2031 on November 14, 2008, releasing underground material that could be analyzed by the orbiter for the presence of water ice. Discovery of water. On September 25, 2009, ISRO announced that the MIP had discovered water on the Moon just before impact. This announcement was made after the discovery of water was announced on September 24, 2009 by Science magazine by the NASA payload Moon Mineralogy Mapper carried on board Chandrayaan-1. MIP discovered water on Moon before NASA's Moon Mineralogy Mapper. The announcement of this discovery was not made until NASA confirmed it. This gave the answer to the millennial-old question whether there is water on or in Earth. A unregistered trademark S-Moon when it led to the discovery of water in its vapor phase by the Chase payload on board the Moon Impact Probe and complementarily in its solid phase by the Moon Mineralogy Mapper payload on board the main orbiter in the Chandrayaan mission. This discovery class of finding unregistered trademark by Chase was achieved by direct in situ measurement of the lunar atmosphere during the descent journey of the MIP to the lunar south pole, while M3 discovered water in ice form by remote sensing techniques. As water cannot retain its liquid phase in the lunar environment because of its own vapor pressure and the ultra-high vacuum prevailing there, it can be found in solid and gaseous phases. While the Moon Mineralogy Mapper, a payload by NASA, onboard Chandrayaan-1 lunar orbiter has detected, by mapping almost 97% of the lunar surface using remote sensing techniques, the presence of water in ice form in higher latitudes, especially in the polar caps. The Chase payload in the lunar impactor has directly detected water in its gaseous form along 14° E meridian from 45° N to 90° S latitude, with a latitudinal resolution of around 0.10 and altitudinal resolution of 250 m from 98 km altitude till impact. See also Chandrayaan-1, Exploration of the Moon, LCROSS, List of current and future lunar missions, lunar water, Selene. References